All right, so we all met Don yesterday at the career panel. So I don't know that he needs much of an introduction, but he's part of the Scientific Software Engineering Board here at eScience, which is sort of a new push by eScience. I don't know, actually, do you want to talk a little bit about SSEEK? Just
Sure.
like a little spiel at the beginning.
Yeah.
And he's been working a bunch on, I mean, lots of things, but among them, agentic AI and how we're going to approach that as a department. But today he's going to be here talking about Python environments and how to manage them. So thank you, Don.
Thank you. Yeah, I'm Don Setiawan, and I am a principal lead research software engineer at the Scientific Software Engineering Center, where we help basically build software for researchers and deploy them and so on. And one of the very important thing about building software is some sort of reproducible environment so that your teammates can actually test out what you're building or you're running whatever different tests. And so this is actually a pretty generic thing here where I say Python projects is actually can be any sort of project as long as they are in this Conda Forge channel. So just sort of show of hands, like how many of you have used like Conda to manage your environments? Oh, sweet. Awesome. That's quite a bit. That's good. How many of you have used UV? Okay, less people. And okay, great. Well, that's good. So Pixi essentially marries the two, and you can work with those two, seamlessly. So today, what we're gonna learn is from zero to reproducible environments, so that you have one manifest, one log file, no activation. You can, have a reproducible project. And so hopefully this is going to be useful as you're working through, creating repositories for your projects, writing code for it, and stuff like that. Cool. And just to this tutorial is good if you like follow along. It's meant to be a follow along type of tutorial. So definitely open up your laptops, go to the Jupyter Hub. All of the materials are in Jupyter Hub. So where are they? They are in curriculum, and there's this L Setiawan Pixi. And if you can either pay attention to the slides, or I have actually created these bunch of markdown file you can read through and follow along that way too. If you're like, I already am very familiar with Conda and stuff like that, I just want to check out Pixi. Feel free to do that as well. Um, and I do have a helper here. This is Shatich over here, and he will be helping. So essentially, if you are ever stuck at any point and you need a hands-on help, he will come around and help you. But other than that, if you have just sort of a general question, just raise your hand and then we can answer those. So, all right. With that, so who am I? So I've built up my career building scientific software and systems. Right now at SEEK, but really at different organization. I have an oceanography background, oceanography roots, where I've led a really big ocean observatory initiative program here at the UW and worked at the Applied Physics Laboratory and so on. I am an open source contributor. I've maintained or contributed to 200 plus repos in GitHub, and I am a Conda Forge member, so I help package, putting packages into Conda Forge so that everybody can use that. And yeah, build toolboxes, any Python toolbox, geospatial and analytics, and so on. And what I do outside of work is I love photography, guitar, electronic dance music, and the outdoors. So yeah, there's a bunch of links about me if you want to get in touch with me. That's about me. So if you have the Jupyter Hub open, let's open up a terminal and just pull the latest version of the repo. So that's what I'm gonna do now. So there should be a terminal here where,
I did not know you could do that.
oh yeah. So yeah, hopefully you guys can pay attention to the bottom here. Let me make the screen a little bigger so everybody can see. Can you guys see my terminal down there? So I'm gonna just run through Pixi and you can still see the slides. So there we go. This is a new way of delivering slides that I'm currently trying out. So thank you for being my guinea pigs. Okay, so if you go to the terminal and you go to CD, the curriculum, you should be able to give poll. And then if you do Pixi version, you should get this version. Everybody should have the same 0.72.2 version of Pixi. So yeah, that should be pretty straight, right? And then you're ready. And so the 6 lessons that I'm going to cover today is why Pixi? What makes Pixi different than like Conda or UV or any sort of package manager that you have or environment manager? And then after that, we'll create our first Pixi project and add dependencies to it, right? And then after that, we're gonna talk about tasks and log files and what are tasks, right? It's not pretty familiar, pretty common in this sort of area. And then after that, we'll go beyond just one environment, right? Maybe in Conda, you have multiple environments. And Pixi can manage those things. And then after that, we're going to talk about for package maintainers. This is really for more like, okay, I want to formalize whatever data analysis thing into a package. How can I use Pixi to help me with that stuff? And then going further, right? Multi-platform locking, CI, Pixi Global, which you can manage global environments. This is a little bit of the one of the big difference between Conda and Pixi is that Pixi, you think in sort of a project space instead of this sort of a global environment space. And we'll see what that looks like. So why Pixi? We'll name the 2 failure modes and we'll say what Pixi adds over Conda and pip. And then we'll confirm the hub setup works, with all the Pixi stuff. So, have you ever run to the scenario where you get a repository that you have a requirements.txt and you have an environment.yaml? How many of you have come across that? Okay, right, it's quite a bit, right? And what do? You're like, okay, how do I install the requirements.txt? You use pip, right? Pip install requirements.txt, and then okay, the environment YAML. Oh, somebody get environment YAML. Great, I can use Conda. So, all right, the step is I'm gonna create the Conda environment from environment YAML, and then I'm gonna make sure pip is in the environment, and then pip install the requirements.txt. Cool, but then something happened. It fails to solve. There was some package mismatch that happened, or it solved, but then when you try to import, it crashed. Right? This is like maybe a repository that haven't been touched in like 2 years, right? And then maybe, okay, the thing runs, but then it produces a different number. So like, oh, did it actually install the right version of that package? Did NumPy update to a NumPy 2? And then now all of my rounding errors are happening, right? It's things like that. So yeah, so those are, like the problems here when you have these multiple different ways of managing your dependencies. It's really hard to really pin it. So, well, what do you think one solution that might work to like make sure this sort of thing doesn't happen? Just shout it out, whoever wants to be brave out there. Yeah.
Maybe have a particular version numbers in each of them and not just randomly download managers. Some packages will do that. That will most likely not crash, but that can still crash. Something changed in the old versions, but less likely.
Yeah. So he said that, yeah, you put some sort of version number into these requirements state C environment YAML, you just make it an open version, which sure, that works, right? You make sure the version is, but the binary has changed for some reason. Or, you're actually downloading a different, the package maintainer decided, oh, I'm gonna put up a new binary, and so now you're not quite getting the right the same binary every single time, right? Things change. And it's not really bad luck, right? It's just the default outcome. These systems weren't built to do that. I mean, there are things like pip freeze or conda env export, which gets you that specific like hash, the platform build, and so on. And there's like conda lock, which is a separate package that you have to install within your conda environment, so you can lock the conda environment file. But yeah, and then name conda environments are shared like long lived. So, like you pip install in the wrong terminal or something. The environment from other project depend on is different tomorrow than today because, maybe you install it a month later and things have changed, even though you've tried to pin it. But again, it's like ever changing because you're not locking that specific build for that specific package. And then again, like also have you run into this sort of more the activation of condas, like it's almost like invisible state, right? So for example, here, this notebook, right? I do which Python. Okay, that points me to an environment, the notebook environment, right? So if I conda deactivate, and then if I don't pay attention of like this little notebook thing, I'm like, okay, cool, I'm gonna run Python. So let's do which Python. This is actually within the root. But then like, what if I have a system Python that I actually want to use because I don't want to use this for some reason? Like it's not very clear. Like there's no way for me to easily just like, I just want to run this in that environment over and over again. So the two failure mode is the drift, right? The packages change over time, and then the non-reproducibility, where it's like, yeah, you could, things aren't fully locked in, so you can't reproduce that bit by bit, over time. So, okay. So really what does it mean to be reproducible is we want some sort of same inputs, same environment, and you get the same output on anyone's machine, right? Here's another scenario, okay? You've built a conda environment for my MacBook. Now tomorrow I have this nice environment YAML file. Now I'm heading it to somebody in Windows. What typically happens sometimes, what happens is that maybe there's that particular, I don't know, niche package that's not available in Windows. And you did not catch that. Now that person who's trying to run your pipeline can't run your pipeline. That sucks, right? Or like, reproduce your research. That sucks. So yeah, it's one of those like, it works in my machine type of problem, right? Have you ever heard of that? Where it's just like, it works mine, but not for you. So sorry. So what does Pixi, do differently from the whole thing with like conda and pip? Well, there is this like, instead of a shared named conda environment you activate by hand, Pixi is, again, as I mentioned, is a per project environment tied to that folder, so that repo. So per repo should have like one Pixi configuration that contains all of your environments, define all your dependencies and stuff like that. And then there's this notion of Pixi lock. So this will lock your specific binary file for that dependency, and it will resolve everything ahead of time. And it will be written automatically as you're actually like Pixi add package and things like that. And we'll see later what that looks like. And then this is one of the beauty about Pixi is this notion called tasks in the manifest. So you could run Pixi run some task, and it will run that task, and you can specify which environment to run that task. So now you have the same exact environment for whatever pipelines that you're running all the time. So, and you can have the task like a chaining task and stuff like that, because sometimes you might have instructions to run a shell command in your README, but not necessarily, there's not really any place for you to put that in a conda environment, right? So this way you can define that with your dependencies. And then yeah, Pixi run has no activation ever, as I mentioned earlier. And then also you can manage both like pure Python packages from PyPI and Conda Forge in one manifest. So you can pull PyPI packages and Conda packages at the same time. So it's pretty magical. You'll probably won't use Conda ever again after this. But yeah, at least that's what happened to me. I've thought Conda tutorials for a long time within all the hack weeks. Noah can vouch for that. And, I think it's the first time I taught, Pixi. So, but you might say, but UV already does this, right? has locking and it can do all of these things. Well, the problem is UV is very much specific to Python only packages. What if you're working with different, multi-language type of problem? Maybe you're running your statistical analysis in R, and then after that, you're doing some other pipeline in Python. You can manage all of that all in one thing because you can pull R packages from CondaForge and so on. And so the magic here is that the Conda Forge piece, the group that created Pixi have this they use this software called Rattler, and then PyPI for the PyPI packages, they actually use UV under the hood. And so and then what the magic of these solving is called they merge them into using this Resolvo, which is the one SAT solver. And that gives you this Pixi lock. And yeah. So the two different like the configuration for these different packages is you use brackets dependencies for Conda dependencies, and then very explicit PyPI dependencies for the PyPI dependencies. So they're following sort of the Zen of Python, explicit over sort of implicit type thing. So yeah, so let's run an example that I've created, a very simple one. So if you're in the curriculum directory, just cd Setiawan, just follow along, and then if you do Pixi run analyze, there's gonna be a little bit of warning, but that's okay. This will run a Monte Carlo. Oh, hang on, example. Sorry, Setiawan Pixi example. Yeah, you see how it's like, I don't have a Pixi toml, a PyProject toml, it detected that. It's like, what are you doing? You don't have any environment. So, but if you do that, you see what it's doing right now. So I haven't run this yet. So it's actually resolving and installing the packages. But if you already have it, it should just like run right away. It should take a little bit, but yeah, go ahead.
So I noticed you're not in the notebook environment. You don't need to be.
No, you can be in the notebook environment. Let's actually, thank you. Let me just cancel. Maybe not. Okay. I'm just gonna wait until that installs. But you could be in a notebook environment. Doesn't matter. Pixi does all that stuff. Even if you're already in like deep into multiple layers of Conda environment, you run Pixi, you will just read that local configuration and be like, oh, I find a Pixi environment, configuration. Okay, now I just messed up this thing. Beautiful. Okay, well, uh, ooh, nice. Thank you. Okay, so let me just go back to notebook. It's all right. Pixi is pretty good. So let's try it again. But there's this question: what information must Pixi have stored for every one of us to get bit identical numbers? Just now, I think I already kind of gave that answer. What do you guys think? What do they store the information? Anybody? They store their binary, exactly. So they store essentially the lock is just a definition of the URLs to the binary that's needed. Oh, look at that. I didn't like. Okay, let me just kill some of these terminals because it's like, hey, you already have a. Okay, let me start over. Goodness. Live demos. It's okay. We're learning Pixi. Right there. Okay, so let's go back. Sample, Pixi run, analyze. But at the end of this, when you do actually run analyze, you should get that number, which is your pi estimate. This is like your Monte Carlo estimation. Pretty straightforward. It's nothing fancy. I'll let that rank through in the background as I, go along. But three pieces that happen when you do run this and this whole installation thing happens is that there's these three things that are in example. So let's look at that. See, there is a Pixi toml, which is your manifest, a Pixi lock, which is that sort of the URLs to the binary, and then you have tasks, which is define that like the analyze task. So let me look at show dish. Okay. You can see here, this is the Pixi toml. It looks like this, right? I've already set this up where I just call it Pi Monte Carlo. The channel, this is which Conda channel that you want to grab from. Pixi by default pulls the Conda Forge, which is a community channel. And then this one, it says built for all platforms, which is the Linux, the OS X, ARM, and Windows, so that anyone that have these three set of architecture can get the same exact, whatever I'm running here. So it doesn't matter if you're running in any laptop. And then the task, the analyze, is that it basically just calls Python, and then there's a script called analyze, right? And that's a very simple task. And then dependencies, right? I use NumPy to do some of this, and then matplotlib to export the plot at the end. And this is stuck. Oh man. I was hoping it would be. Okay, that's all right. Let me just. I'm just gonna go through the slides for now. How many of you have been able to actually run that command? Did anybody try it?
Still running.
Still running, okay.
It's very slow.
Yeah, it has to install the thing at the same time, so maybe it's a little bit slow. Yeah, I didn't realize it's gonna be like that, but that's okay. So yeah, we'll next we're gonna create our first project. So number 2 is let's create a first project from scratch. We'll add some dependencies. And I'll explain. I'll show the Pixi.lock. I showed the Pixi toml, and then there is a folder in your repo once you actually run that called .pixi, and what that is for. And then yeah, run the code without activating anything. So let's create another command. So you could just, yeah, you could wait for the other piece. Oh my gosh. Sorry, guys. Here we go. Back here. One annoying thing, it goes back, doesn't keep the, oh, there we go. The state of the slide. Okay. So if you go back to curriculum, what we can do is we can run Pixi init scratch. So this scratch folder doesn't exist yet. And then Monte Carlo. Basically, we're gonna recreate what I just did. Pretty straightforward, but it gives you sort of the exercise of creating a Pixi. So as you can see there, when I did that, it actually created the directories that it needed, and then it created your pixi.toml file. Oops, cat. So this one, I'm just gonna show you what that base TOML file looks like. Essentially what is shown there. So we created, you see how it defaults to channel on the porch, name Monte Carlo, and it detected the platform that I'm in. In the Jupyter Hub, we're in the Linux 64 platform, so that's what it did. And then just an initial version, can be anything, and then an empty task, and then empty dependencies. We haven't had any dependencies. We don't even have Python, right? So if I do, now if we go to scratch Monte Carlo, come on. Right, Pixi run Python. Oh, I think is this caching dir that's happening. So what this is trying to do is try to cache some things. Where is that coming from? Oh, I think it might be getting from a different cache. So if you do a Pixi run, it will run in the default basically environment. And that default environment is your whatever's underneath dependencies. And later we'll see different environments. So this actually, what happened was that when I run Pixi run which Python, it actually detected that I'm in the notebook. So there is no Python in the Pixi, but then there's this, I have this, the notebook underneath, which has Python, and it went to that. Just, it's a little interesting. But yeah, that piece is how it works. But if there is Python, it will use that one. Okay, let's continue on. So for those that are following along, let's just get rid of this warning. It's pretty straightforward. So export Pixi cache dir equals whatever this is, temp repo data. So now that warning should be gone. But I'm gonna add Python, I'm gonna add NumPy, and I'm gonna add matplotlib. Okay, so when you add these things, so what happened when you add, and remember those platform, and it says Linux 64, what it's gonna do is solve for my Python dependency, the Python package, and then solve for the NumPy package and the matplotlib package for Linux 64 only, because that's what you're referring to. But for the example that I showed you, which has 3 different platforms, the reason it was taking a long time was it was trying to solve for all 3 platforms, making sure that it works for all 3 platforms. So do you see any advantage to this of sort of the solve ahead of time thing? Anybody? What do you guys think? When you solve ahead of time, what advantage would that bring you? Nobody wants to say? Okay. Well, I mean, it helps you making sure that it works for everybody, right? Because you, as the person creating whatever package or creating this Pixi environment, you have done the hard work to figure out what dependencies work for this specific thing that you're trying to do. And then you're like adding different architecture to that to make sure that whoever you hand off this Pixi project to can actually run that thing. And everything's already solved. And it's all in the log file, which shows the specific binary.
So there's a question from online.
Yes.
It included my name and email in the pixie.toml. How did it know?
Great question. It does include your name and email. If you have, like, for example, there, oh, that's very little. If you have your Git set up. So Pixi assumes that projects use Git. So if you already have Git set up, it will take the information from your Git setup. So that's how Pixi knows about you. Not really, it just scrapes Git. But yeah, there's no AI in Pixi, so just
I
throw
also
it out.
have a question.
Yes.
So my question is that sometimes what I have felt with Conda environments, or just generally when I'm setting up the environments, is that sometimes I would make edits to a certain library because of, whatever issue it's kind of incompatible, or yeah. So I would go and like maybe I had edited a Python file in that library, and then when I would later generate the YAML file from the Conda environment to be able to later set up it in a different maybe cluster, I would see that those changes aren't really translated. So is that something you could, so yeah, it wouldn't exactly be the same environment I'm setting up in a different place if I had made any edits to the Python files inside the library. So I wonder if Pixi has some kind of setup to account for such things.
Um, Let me understand your question. So you would basically specify the exact the conda dependency within your conda environments that are like, directly, this particular binary that works for whatever computation you're trying to do. Is that sort of, and then it doesn't really work within conda where it tries to resolve that within the greater scheme of things?
No, I think what I was trying to say is that, for example, I have made some edits to this like PyCortex that is a plotting library in
Okay.
the Python files, and so, that would work perfectly in that environment, and wherever, like whatever HPC I am running it on, like it would run perfectly fine. But then suppose I'm trying to copy that environment entirely to a different place. And if I'm doing the conda environment, if I'm exporting that as a YAML file, it is going to take into account the version and everything, but it won't really know or even track that I had made a few manual changes to one of the Python files in that library. So it won't really be proper copying, being able to copy over that environment to a different place, because it hadn't, yeah, it doesn't exactly work that way. It doesn't track such changes. So yeah, I'm just wondering if
Okay.
Pixi has a setup for that.
Yeah, I think this will be covered here later on the if you're a project maintainer. Essentially, my understanding, what you're saying is like you have some sort of local library that is, you're installing, but then you're also creating a conda environment for that library. But then you're like, okay, I'm gonna port this library and try to run it somewhere else. And then there's not really a way to make sure that same, you make an edit, that same library transfer over, right? So, I mean, in that case, then yeah, with Pixi, it can do that management for you because it can, later you'll see that it can point to even just a folder of, where you're creating those library, and it will solve for that and its conda environment at the same time. This is where that whole pip and conda merges together. I hope that makes sense.
If
Yeah,
I
go
can
ahead.
add, this is a problem that I've come up with pretty frequently because I'll edit a library to try to make it work with something I needed to work with.
Yep.
I usually clone it on GitHub and then add, or fork it on GitHub rather. So I have my own copy of it, edit it there, and then you can direct install from GitHub for most of these tools.
Yep, you could do that.
So
Yep.
that way
Yep.
you can track it across environments.
Thank you. Yeah, yeah, definitely. That's a way to do that as well. Yeah, you put it on GitHub, you make a change, you refer to that, which Pixi has the ability to do that piece.
Oh yeah, I think I was mostly referring to libraries that are like well established, not written by me, where
Right.
yeah, make
Oh,
a little edit, and I can't, I guess, like make edits or changes to that library, but yeah, I had
but
to
you have
make
your
some
big.
changes like locally for my
Yep.
setup, and those changes just do not really roll over with Conda. So yeah.
Yeah, with Pixi, it can. So
Okay.
that's, yes, there's a way to do that. I don't know why this is not writing. Okay, well, are any of you able to follow along or no? It's not working in the Jupyter Hub.
Just thinking.
So just thinking, okay. Well, you could follow along locally, maybe. Or will, huh?
Because if I run it locally, it works.
Yeah, locally it works because it's just your own laptop. Maybe it doesn't have enough, RAM or something to solve, and everybody's trying to write in the same, I think it's some sort of NFS file. So apologies, this is our first time running Pixi with the Jupyter Hub setup. And yeah, definitely you can try it locally if you'd like. Just install Pixi.
So for what it's worth, we've been having a little trouble with the Jupyter Hub because GitHub has been having some weird outage things, and it might be that there's something going on.
Oh,
Especially if
yeah.
it worked yesterday or something.
Yeah, it worked when I was running it on my own. So, but if you want to install Pixi, the instruction is here. It's pixi.prefixdev. Yeah, or pixi.sh will get you to that page. And then if you have that, then you can follow along that too.
I think I already know what's going on. I think Pixie needs to write to its location, and it's in a read-only process.
Oh, it had no problem with,
Okay.
yeah. It's okay. Definitely we'll try it. You guys can try after this. But yeah, I'm gonna keep moving on. And here's just the command if you are gonna run Pixi without activating. As I shown earlier, I ran Pixi run which Python, which gets you there, which gets you the Python. But since it didn't exist, it actually grabs from the notebook since you're activated in the notebook. Conda environment. So we will just grab that. And yeah, and then, but if you like, having the Conda activate type thing, Pixi has a thing called Pixi shell that would actually shell into your environment. And it works similarly like Conda, where it will give you the environment name in parentheses. And so then you can just, run whatever commands that you are within that environment. So, yeah, either way, there's no global environment to remember to like deactivate if you're like switching from one Conda environment to another, and then you're not like, oh, I'm in this project now. I'm just like, oh, which Conda environment do I use for that project type thing. You don't have to think about that, which is helpful. Yes, question.
So I know we're unable to run along and try it out, but could you explain more? How does it do that? For example, I might prepare two different Conda environments because I know some packages within won't talk to each other. So how does Pixi bring them all to the same table and still get the job done?
Yeah, that will be covered just a little bit later,
Okay.
where multiple environments. So you can manage multiple Conda environments within Pixi. So yeah, so I forget to mention that Pixi was developed by this guy called his name is Wolf, and he is actually one of the core developer for Conda. And what he did was he used the same sort of Conda primitives to build Pixi. So that's why it works really well with Conda. And the way, later we'll see a .pixi directory, which allows you to see that each environment is essentially its own directory and things like that. And you can really specify packages for that environment so that if you do run into packages that might work, that might solve for one set of dependency, combination, and then it doesn't solve for a different one, you could create two different Conda environment or Pixi environment, and then you can work between them. Man, there's a whole exercise. Okay. It's a bummer. Let's see if I can do.
So pretty much everyone here about turn if you want to just show them install it.
Okay, yeah. Let's install on our own terminal. Looks like everybody's using some sort of.
Does anyone not know how to open a local terminal? If you do, raise your hand.
You need,
On a Mac, you can- or go to-
yeah, raise your hand if you need help opening your own terminal in the in your laptop. And then if you go to Pixi, so if you open your web browser, pixi.sh, and you go to getting started and installation, just pick which operating system you're in. If you're in Linux or Mac OS, you just copy this curl command and then open a terminal. Let me see here. I'm gonna open up terminal. Okay. You just make sure I have the, okay, we're good.
Can you hear me?
Yeah.
Yes.
First time I run, I installed it locally. First time I run Pixi run, which Python is it supposed to return empty?
Yes, which Python, if you're locally and you've never installed Python, it should run empty or Python
no.
not.
Okay, but do you mean like installing Python system-wide or in with Pixi?
System wide, or
I
if you create a new Pixi without specifying Python as a dependency, there shouldn't be any Python in there.
okay. We are going to
Unless you have a
check it.
Conda, yeah, unless you have a Conda environment activated, which we've seen earlier that Pixi will find that and then use that.
Got it. So now we are gonna make it install a Python binary.
Yes.
Okay.
Yep. So, and then if you have cloned the curriculum repo, do you guys know how to do that? Or you have that locally somehow?
Just so they get it wrong.
So Don, could you zoom in a bit?
Oh, yes.
To the back, it's a bit hard to see.
Sorry. There we go. Git clone. Oh gosh. Remember let's see here. Git remote. So it's this guy here. Can you Slack that to everybody?
Yes, I will.
Yeah.
I will Slack this to the channel here.
Yep. So if you clone that, you'll have, this is my copy of it. I just named it differently for, it's my own fork, but you should have like curriculum. If you ls, you should have the same thing as what you would in the Jupyter hub, where you could do Setiawan Pixi. You could see there, same thing. So yeah, let's just follow along Pixi init.
Zoom is not seeing your terminal.
Oh, sorry.
Oh.
That's
Oh,
right.
Zoom's
I need to change. Yeah. How do I bring back the Zoom?
I think if you push escape. Weird.
Here we go. I'm just gonna share my whole screen. Hopefully I don't show my emails to everybody. Okay. So yeah, so now you should have now you could do the follow along the Pixi. Okay. Pixi init, scratch. Carlo. Okay, you can see there. Now if you do CD scratch with the Carlo, so now you can just see that I only have Pixi Tomo. There it is. It's, you know, it's like my system architecture now instead of the Linux 64. Now you could do Pixi add NumPy, or you can add Pixi add Python because we need Python, we need NumPy, and then we need matplotlib. And this will resolve fairly quickly. You can see there, very fast locally because it doesn't have to worry about that Jupyter Hub stuff. And now if you do cat Pixi Tomo, you can see there it pinned it. But here's the nice thing now. You see, earlier we only have Pixi Toml, but now I have Pixi lock and this directory called .pixi. And then, I created the get ignore to ignore this directory. And then the attributes, which allows Pixi to work with your Git. And you might be wondering, what does the Pixi lock looks like? It is a big file. You could see that, right? So here's an example of, so there is a library called ZTSB, which is, I think, used in NumPy. And it gives you the exact binary URL. So something Honda is your binary. And then your signature, your SHA-256 signature, and then the MD5. And then this gives you sort of like the other metadata about that, and gives you the timestamp so it knows when it was downloaded and things like that. So this Pixi lock is very helpful. This keeps that specific basically installed. So now, I want to make sure that my colleague that's in Windows can also, get the same setup. So, open up your favorite text editor. I don't know what that is, but I'm just going to open up VS Code, which there's no VS Code. So, this has been pretty simple. So I want to make sure it's just to demonstrate the power of the ahead solving. Okay, so now Pixi install, it resolved it. But now if I do cat lock, you will see that there are other, let's see. So if you go to the very top, so here's the list of packages within the ARM64 Apple, and here's the list of packages within the Windows 64. So now you have the exact one for the specific timestamp that you have installed this thing or locked this file. And so what that means that even if you try to run this again 6 months later, it will still work, assuming that Conda Forge and Anaconda don't, go kaput as a company. So yeah, so everything is work. Actually, Prefix Dev as a company, they have a mirror of all these packages too. So everything's all backed up. But yeah, so that's the kind of lock. Okay, so now we've caught up. So this one is just adding more, essentially, this exercise is adding more packages. You can add more packages, but just saying Pixi add whatever. And if you need a specific version, you could do Pixi add, like this one, adding rich. You just put that specific version. Same thing like your Conda or your or pip. So there's nothing different there. And then the one thing that I do want to show is, say here, let me go back to my terminal. So I'm going to add rich. And you can see here, if I do like rich Python, I have no Python, right? So I can't do anything. But if I do Pixi run Python or Pixi run which Python, you see where that goes? It's actually within my path, Monte Carlo, and then the directory called .pixi. And that's where your Python binary lives. Again, it's within that. So, I just, my computer is running out of space and I want to just delete this. You could do, there's a Pixi clean, which will delete your .pixi file, because what matters in Pixi is the two combination of Pixi Toml and Pixi lock. You commit those things into your Git so that you have that reproducibility-ness of it. But yeah, so now if I Pixi run Python -c import rich, that is not very fascinating. I'm just gonna do that. Let's get you. It works. So what happens is Pixi run. This is the default environment Python, and that's where it's gonna run it. So that's that. I'm gonna speed up a little bit faster here. So I mentioned earlier, Pixi Toml is your intent. So it's define kind of like your environment YAML or your requirements.txt. You define all your dependencies here. Pixi lock will give you the exact solution. You don't ever hand edit your Pixi lock. Just leave it be. It will auto resolve itself, and yeah, you just ship it with your your repository, and you have that. And the .pixi folder is disposable, so this actually goes into your git ignore. If you do cat.git ignore, you could see there it's actually ignored because this is just where your actual binary will be downloaded to. So it's all local. It doesn't mess up any sort of system setup that you have. Every single binary is installed within your local project directory. Okay. Any questions so far? Are you guys trying it out in your local thing now? Okay, cool. Okay, let's go to the task and the log file. Well, we already talked about the log file, but yeah, I think I've already shown you the records of the log file. I'm getting a little bit ahead of myself, but let's look at the tasks and what that looks like. So earlier I had this analyze. Let me just close this. There we go. I have this analyze script right in the example. So let's bring that in, the analyze script in. So what we can do is just let's copy ... I think it should be an L, or sorry, copy ... L Setiawan Pixi examples. There we go. Analyze.py, just copy it into this repo, or yeah, in this directory. You should see analyze.py. And then now we want to Pixi task, add analyze. And we want to make sure that it runs Python analyze. So this is the command. This can be anything. This can be any command within your script. So if you have a bash script and whatnot, you could put that in here. It's just like, yeah, it's just putting in command in your terminal. Okay, so now it says add a task, analyze. So now if I do Pixi run analyze, we'll actually run that and get you a result here pretty soon. Which, this gives you a big sample to run the Monte Carlo, and this is actually yeah, there you go, you got pi estimation there, and we'll do some plot. Yeah, you could see there, just little half circle type thing. But you could see how that's helpful. And here another example is you can add a task for a quick sample, which just gives you 2000. So I'm just going to copy and paste. And now if I do Pixi run quick, it will run that same thing, but with samples 2000. Here's one little magic though. Pixi allows for chaining of commands. So even though I have, Pixi run analyze, like that, remember this Pixi run analyze actually under the hood Python analyze.py, but then that's a CLI that can take argument. For example, this like quick samples 2000, you could chain the command samples 2000. this is the same thing as running Quick. And there we go. So if you're like, oh, I have, a command, a CLI that I want to run in this specific environment, and I know that I can chain those commands together, and I'm not like, I'm just still experimenting. Maybe there's another task that I can add, but then I'm not quite sure what all the different arguments should be for this CLI. Then you could just play around first and then create another task for that specific thing. So yeah, it's pretty nice that way. It can also take arguments, environment variables, and so on, which I'm not going to cover in this tutorial. But yeah. So, and then let's see what that looks like. Oh my gosh. Give me 1 second. Let me hide this floating. So now our tasks is filled in right there. You can actually hand edit these things. So if there are more complicated tasks that you can, set up, and you just basically edit your pixi.toml in some sort of editor, and then you try that. And then you run. You can then run that after. So let's see. Okay. And I'm pretty sure like a lot of you maybe have like make files and like commands that you put in your readmes, but there's not really a way for Conda to just like run it. Well, now with Pixi, you could just put those commands into your Pixi tasks, and anyone can just run that commands. Super easy.
So,
Oh yeah, go ahead. Question?
so basically, a task is just like an alias.
Yeah, it is like an alias. Exactly. It's like
It doesn't do anything else other than that.
No, it is an alias. It can take arguments, it can take environment variables and things like that. But that's
Can it be like, I mean, yeah, sure. If I was gonna ask, could it be an entire script? But obviously, it can. If
no,
we
it
have,
can't. You can't put like a full like bash language in there. I mean, you can if
if we
it's
have the script, like we can just add it as a task.
yes,
If we have,
exactly. Yeah.
yeah,
If you have like pipeline.sh or something like that as a script, and you want to
exactly.
just run it, you could add it as a task. Right, exactly. And that script will now run in that specific Pixi environment. So that's the nice thing about that. Yep. And then you can specify later. I'll show you here in a little bit how to change different environments. But yeah, I'm gonna go through a little bit faster because I only have half an hour left. And again, you could remove your .pixi directory on purpose. So we can do, oh, doesn't work. I don't have tree. I thought I do. So let's just remove that. So it's removed. So, but no problem. I can still run it. You see how fast that was. Like it will still solve that, but then it doesn't have to recompute its solving because it already has the lock. So what it does is it'll just download the thing. And there is also a caching mechanism where some of the packages are cached within your system. That Pixi cacher warning that we saw earlier. Yeah, that's so then the the setup for the environments are really fast. Okay. Yeah, so here's something to think about. Your collaborator runs this project next week, which file guarantees they get your versions, the manifest or the lock. It's very easy. Simple. Anyone? The lock, exactly. Yeah, and with that, like, this just try, I think sometime this week, try create a Pixi project and then just like hand off that project, push it to GitHub, hand it off to someone else and see if they can reproduce whatever environment that is. I think that would be really cool. Hopefully more people are going to be using Pixi for your projects so that I can even try it out. Would love to learn about any neuro stuff, right? So yeah. Yeah, I mentioned the platform thing. This allows us to, solve ahead of time, and you can make sure that everybody can have the same exact thing. And this is a more advanced Pixi feature, but you can target specific platform dependencies. So say one dependency only exists in one platform. Say it only exists in Linux. You could just do target dot, Linux 64 dot dependencies, something like that. And then you list the dependencies that is only Linux. So only people who have Linux platform can get that environment. So yeah, because sometimes some dependencies might be like very restricted in the platform. And oftentimes that's where, right, these contributions of you being a good community member to the whole Python ecosystem of like, oh, I know how to package that up in this other platform or compile it to this platform, then I'm gonna do that and contribute to the greater open source. And that's essentially how I'm like, have contributed to a lot of open source. Is like, I find a package that doesn't exist and I need it for me, but then other people might need it. So I'm just going to package it up to make sure that everyone else have access to that. So it's a great way to get your open source portfolio. And there's the same trick in the CI. So this is one of the CIs just showing you that for this development of the tutorial, I made sure that the example runs correctly. I actually make sure that it says, oh yeah, I'm using a lock file. So it'll check the lock file. If I ever forget to like recompute the lock, so I add a dependency manually within my Pixi toml, but I never run Pixi install for any reason, like this will catch that because the lock file and the manifest now have diverged. And then it will be like, nope, there's this discrepancy here. This package is missing and whatnot. So, which is very helpful for that. All right, so now this is your turn. Create a task called full that runs after quick. And here's a hint for you because I didn't mention this yet, but yeah, so a task called full, it runs after quick has passed, and then it will run the full analysis. So remember the quick task that we had? Let's create a new task that's full that changes them together. How would we do that? Right. Do you guys want to try that out? See if you come up with something. Just go to Pixi task add dash help, look for depends on, and yeah, I'll give you like 2 minutes. Or just shout it out. What do you think that looks like? Or how you do that? You just want to do it on your own? I'll let you guys 2 minutes on your own and see if you can figure that out. Have you found depends on? Depends on other commands. What do I put there? Anyway.
Quick.
Yep. Thank you. No. Oh, a name command.
You get a defined full. So full is Python.
Oh, yeah. Oh, here we go. Quick, yeah, I gotta define full. Thank you.
Just like,
There you go, typo in the pen.
Oh my gosh. Sorry, depends on quick. Boom, full, and then the commands. Just gonna make it full as the others. Oh, why aren't you getting? Oh my gosh. I'm following the instruction.
I think it would be order.
Yes. I think that's a bug in Pixi there I just discovered. Because the doc string says otherwise.
Yeah.
There we go. Okay, so that's pretty straightforward. And that's what it looks like, right? So now we have this JSON essentially. Well, you say command is that, and it depends on this here is the name of whatever other task that you have. So in our case, it's quick. So what happens now if I do Pixi run full is that you could see there, quick happened first, and then full happens. And that's how you can chain things. So maybe you have a pre-analysis, post-analysis, you can chain that. So you have any sort of pre-processing or whatever, you could put that as a task and then do the rest. Which is nice, right? Because now you can have this sort of dependencies. It's kind of like makefile, but it's Pythonic, and you could also still, call make and stuff like that if you are familiar with make. But yeah, essentially that's what it is. Yeah, so the reproducibility contract, so this just makes it tasks make projects self-documenting, so all the commands live the Pixi toml, not in your head, so you don't have to remember about aliases and things like that within your own environment. You could just put that, define your task for that specific project within your Pixi, and so that anyone can run similar things. And that's what you document is like, run this task. And if you already know the order of chaining, then put that as a dependent task that depends on each other. And then, yeah, the lock file is the contract. You have the exact version hashes per platform. So those two are the things that you commit. And yeah, you could use, again, like the CI and GitHub. Definitely watch the other session later, since you're in this session, about the GitHub. And gives you actions and stuff like that. And yeah, you could use Pixi within that. So now beyond one environment, okay. So the problem with one environment, your users need NumPy, matplotlib, enough to run analyze, but then, like a good thing in software is you want to do some sort of testing, right? Maybe some sort of numerical test, but then you don't want that to exactly, if you're the developer for that software, you want to run the test. If you're just a user, you don't need to get any packages that is with a test, with all the dependencies for your test. And so how do we do this, right? I guess a lot of you might have used pip or maybe like, in like PyProject toml type thing. How would you set up a Python project with some optional dependencies? Like, what does that look like? Anyone? Groups.
Dependency groups.
Right, exactly. You have dependency groups. You have like optional, dependencies block within your PyProject toml. That often happens, right? So that's what you do. Or pandas amazing traditional fix, which I've dealt with this back in probably 5 years ago, is that you have an environment.yaml that is your regular dependencies, and you have environment.-dev.yaml, which is your dev dependencies, right? So you have all these different YAML files floating around. Or if you're working with like Jupyter Hub stuff, you got to define all your dependencies all in one giant environment, which sometimes don't solve. And that makes it hard. The more dependencies, the harder it is to solve. So thinking about how can I break down the dependency so that it can solve properly, and break it down to what specific environment do I need for that specific run or that specific package or task is the thing that should be starting to think about when you're working in the world in Pixi, really any other one. So Pixi's answer is they have this very, a small set, almost like dependency groups, a small set of what's called features. So features is essentially a named group of extra dependencies, right? And then that's a very small group. Just think of it like you're building your little Lego blocks, right? You might have a Lego blocks that's shaped like a triangle. You have a Lego blocks that's a square, and then you add them together. You can create a little Lego house, right? Same thing like Pixi. So you want to define your set of dependencies as features, and then the greater environment, you want to take, that triangle, you want to take that square type thing together to make an environment. Yeah, and then the default environment is still just dependencies. Like we saw earlier in the Pixi toml, everything else is just opt-in. So I'm just gonna run through this real quick. So here, Pixi add feature dev PyTest. So I'm gonna add a group of environment called dev, because I want to be able to test whatever numerical analysis that I'm doing. And so I'm creating this group of dependencies at dev. So what does that look like now? So here, feature.dev, that's the name of it, .dependencies is that. So now you can have a list. And the star just means any version, right? The latest version of PyTest. Because I'm in a development environment, I don't really care about the version. It will be locked in during the time I installed it. So that's, if you keep that Pixi lock file in your Git, then you get the same version every single time. And then now to add the actual environment, like you can handcraft this. So this is what it will end up looking like just by going to Pixi toml if you don't want to memorize these different command, or you can create a task around it. It's like very meta. You add a Pixi task to call Pixi. It works. Okay. And there you go. And there is a warning that says basically it's like it's defined but not used in any environment. Because earlier we never added it to any environment, but now we just did. So now it's like the next time you actually run this, it will not give you that warning. So again, let's do cat Pixi toml. You can see there it is. Environments dev is dev. So if I have another feature that's, maybe you have a test and then you have a linting, right? I could do feature.lint, which checks for your style of your code into there, and then the dev would be like your dev and then lint, right? So you just chain that. And then now I have that environment. So how do I make sure that this works? So let's check it out. So Pixi run, let's Pixi run Python in the default environment. So this is the default. So that means is this guy's here, right? Okay, I got a Python terminal. Now, import PyTest. Well, module PyTest, right? Because I am in the default, which the default doesn't define PyTest, right? So But if now I Pixi run, and the way to get into an environment is you do -e dev. Now I run Python. Now I'll explain to you why this works right now. Okay, so Python, I am still using the same Python as the default dependency, which I'll show you here in a little bit. And I can do import PyTest. And it's cranking, and then there you go. So now PyTest is available because I'm in that environment. And just, for your sanity, you can see here, you see run-e dev, which Python, it is, there's basically a symlink to the in the dev environment that is that default environment. So what's happening under the hood is that this, when you define dev equals dev, Pixi by default does this, I think it's defaults or something like that. Adds that default environment in there. So I still have access to NumPy, I still have access to Matplotlib, I still have access to Rich, even though I'm in dev environment. And you might be wondering of like, oh, there's some of these environments that might not work together. Well, there is a specification that says no default, which means that now you have to basically put together your Lego blocks to not pull from the default environments. So it can be a little bit, copy and paste, but that will make sure that the environments are completely isolated. There's no defaults, and that's like, with your JSON kind of like this, and there's a no default type thing. Definitely look at the Pixi documentation for that. Okay. All right, here we go. So I've shown you this, basically same tool, two environments. Yeah, so the default environment is what user gets, what belongs in it, and what have you been making users install that they never needed? Have you ever had the time where you're just like, I'm just gonna add, different packages because it's like it works, and then your users get to install PyTest and things, all these things that is supposed to be just for you, and they're not really needed it. So that's a bloat, right? So and it's not great. But Pixi allows you to really break that apart. Okay. All right, now off to the PyPI packages. I've been talking a lot about the Conda packages. Now, how do I add PyPI packages? So you can see here, it's pretty straightforward. You just do -- PyPI. This thing is here again. So Pixi add -- PyPI, just TQDM, it's just a progress bar type thing. And then now there's the PyPI - dependencies in my Pixi toml. You can see there, now you can define all your PyPI. And the beauty of this is that you see this dependencies. You could do feature.dev.pypi dependencies and then list all your PyPI for that dev environment as well. So it's pretty straightforward how the chaining happens. And that allows you to have that TQDM. So name one package you've only ever found on PyPI. Where does it fit in this project now? It's a pretty straightforward answer that you can put in your PyPI dependencies, because sometimes packages are not in Conda and you kind of want that in your Conda forge. So you don't have to now just pip installing things. You just define it. Same thing like that. I know that in Conda environment YAML files, you could do PyPI : and then you list it out. But yeah, this is really clear of where's the boundary separation and putting it into a different environment that you need. So, and both still land in the same Pixi lock. And yeah. So just in interest of time, this just gives you, another feature called REPL, put in IPython. Pretty straightforward. You could put your Jupyter lab in here. So say you have a data analysis environment that you like your Jupyter lab in here, just to do data analysis, but your users don't really need to have Jupyter lab, right? They just need to run your script, right? Or you're like, okay, you're doing data analysis, you get this pipeline, now you're ready to deploy in HPC. You could just, deploy that regular environment and not have to worry about installing this other one. So yeah, by default, right, these optional environment, when you do Pixi install, it will not get downloaded until later you're like Pixi, -E activating some environment. So yeah, the default environment is your user's contract. So this just, keep your default minimal because this is what your users get to pull in, and everything else just create an environment from that. And yeah, and then as you see, Conda and PyPI coexist in one manifest. And I will show you now. So here's another question, right? There is a way to embed Pixi within your PyProject TOML. Right, so earlier we've seen a lot about Pixi TOML. It's like its own definition. But what if I'm like, I already have PyProject TOML. I don't want to have to create this whole other TOML and then now I manage two TOMLs. Well, Pixi, if you are working in the Python space, allows you to define Pixi dependencies within your PyProject TOML. So there's no more separate environment.yaml file at all. And everything is in there. And I'm gonna show you about the editable install. And yeah, so in the interest of time, again, I'm just gonna walk you through it. I might not run the actual thing. But yeah, everything so far is a standalone sort of analysis script with its own Pixi TOML. With PyProject TOML, though, your pip can read it, right? And your UV can also read your PyProject TOML, and your CI can read it. And so that actually allows for this interoperability. And so if you put all your dependencies as PyProject TOML, now you're not stuck with just Pixi, right? Pixi, if you are developing that software, it helps you, but your users don't have to get Pixi to get the benefits of cloning your repo and then changing things and trying things out. Okay, so I'm just gonna do this quickly. So if you init, again, like earlier, and then this time format is scratch pylib, and then you go into that directory, you'll see this PyProject like this, right? It's similar like the Pixi. It will figure out that like, okay, you're actually now wanting to create some sort of Python project. And so you have the name version, your dependencies, your require Python, and then your build backend. So this actually follows, I don't know if you guys heard of Scientific Python development guideline, but definitely check it out. There's a whole community called Scientific Python Community, which is really great to keep up to date on all these different standards and stuff like that for best creating scientific Python libraries. And then, yeah, so in your PyProject TOML, to get Pixi in there, right, Pixi also set up this thing called, basically, it's like your tool, like your rough tool or MyPy's tool.pixi workspace. And this defines what channel that you have and the platform, similar like your Pixi TOML. And then your here it defines your PyPI dependencies. In this case, since you say that I'm creating a pylib software like library, it will just find that library within your current path, and it's editable true. So what does that mean? Have you guys done like pip install -e and then your local directory type thing? That's exactly what it is, right? It just make it editable so that when you are changing any sort of function, Pixi can detect that and run that. And then this also allows you, there is a argument here, instead of path and editable, you could put URL equals like your Git repo paths and whatnot. So earlier there was a question of like, oh, what if I make a copy of some popular, package out there and I make some change, then I push that change to my repo. Well, you could just do, the name of the package equals URL equals the Git repository. Pixi will install that. We will actually build that and install that, assuming that all your, dependencies are all lining up together. And then again, tool Pixi tasks, that's available in your PyProject TOML, so you can create tasks for that as well. So yeah, so the standard metadata stays the single source of truth. So you can now just, you'll have this within the Python, you have this optional dependencies, right? You can have a test, pipe test. Well, you could, when you add here, what happens here, you install it, and then you can add an environment called test, feature test. It will actually detect that in your Python specification, you already have test as optional dependency. And so it will just add that into your environment without having to copy or replicate your dependency chain. Like earlier, how we like having to create the dev feature and then list PyTest in there. Well, if you already have a PyProject TOML and already have PyTest in there, you can just add that to an environment, and then it will go written into your PyProject TOML. So yeah, try that out. And yeah, so within the tool so now the question is like, how can I add Conda environments? Well, same thing like, you in the Pixi TOML, you'd add dot dependencies or like that dependencies bracket. Well, within PyProject TOML, you just have to put in tool.pixi so that it knows, this is Pixi configuration and then dot dependencies. And this can be really, really nice for like, okay, I have some CUDA dependencies that is not in Python, but I want to make sure that this project has that specific CUDA, version and build and all that stuff. You could specify that in your Pixi. And then, yeah, and then dependency group map to Pixi features the same way extras do. So you use one, in the sort of stretch goal later. But yeah, let's see here. And again, it's just proving that the editable install works. So this exercise just gets you to, have a one command to test, and then adding to a feature here, like picking from that feature and then running that test to make sure that's working here. Let's see here. Yeah, so this becomes, so each feature you can actually have per tasks per feature. So you can have specific, so like test, that dependency group test, and then the tasks within that, specific task maybe, for that set of dependency, I only need to run certain task, things like that. So, yeah, so that's the one PyProject TOML for every tool. Again, just the prepend is the tool.pixi, and that all should map similarly like the Pixi TOML. So going further, there is a notion of Pixi Global. So this was an attempt for Pixi to make it so it's like familiar for people who comes from Conda, right? So you're like, okay, well, Don, you have, all these per project, but I have a set of environment that I want to reuse across all the projects, where you could do that with Pixi Global. So here it says Pixi Global install rough. So this will actually create, let me actually run this so it's more clear. We'll install rough. And this will create what's called here, this global environment. So if I just cat this guy, you can see there, M's rough channel dependencies expose. So expose is just like, how do you want to expose that library? That's part of the environment. So yeah, and you can Pixi global run, same thing. Like you could run a specific environment, or you could Pixi global shell, which feels like Conda. And yeah, and then another thing is like, okay, I have all these Conda environment YAML. I want to sort of put that into my Pixi project. Well, Pixi has an easy thing of Pixi init, like the importing the environment YAML. So it can read directly from your environment YAML and set up your Pixi project that way. So if you have old environment YAML and you want to make sure that like now I can ship that environment YAML within my project pretty easily, and you get the lock file, right? You don't have to mess around with Conda lock. If you ever play around with Conda lock, it's not an easy, trivial thing to play around and mess around. Yeah, have you tried that?
This almost feels like a cheat code we used to have in games to go through.
Yes, it is a cheat code. Yes, it is like a cheat
Just
code.
learning instead of, I don't know, if other people feel like learning this whole new setup and revamping all of the things you did and then maintaining it.
Yeah.
For people who are not software developers, and I just want to get my job done.
Yes.
It seems like a very easy, straightforward thing to do. What are the caveats?
What are the caveats? Well, I think it is an easy, straightforward thing to do, right? I think the hard stuff now is getting out of that mindset of like this Conda environment is pretty much global. Like I have a Conda environment that can work with many different projects to thinking more of a project base. So like for this specific project, what are my dependency exactly for that? That can be a huge mindset change. And then like, how can I break down my dependency into these very like small pieces of features so that I don't just dump all of my dependencies all at once, which happens in Conda environments, right? Oh, I'm way over time.
Just
Yeah, so yeah, I'm just but I'm pretty much done. What you can do now is hopefully you can try out Pixi, create Pixi project, run your code, use Pixi shell. I didn't really, let me just do Pixi shell. There you go. So you can see there, I'm in that shell now. So you can, now you're just working like Panda. So anyways, yeah, and then you can now create multiple environments. So don't be shy to create multiple environment for your project versus before. It's, you know, you can have multiple different Conda environments, but I don't know if you guys have ever run to like, oh, you know, I'm just lazy. I'm just gonna add all my environment in my root global Conda environment. And then now I messed up my whole Conda system, right? No need to worry about that anymore. I've done that personally. I've probably blown up my Conda environment multiple times.
yeah.
Yes, yes. So yeah, and then again, like it integrates with your existing PyProject TOML. You can import your existing environment YAML thing, and now it's locked. So now you can share your Pixi TOML, and yeah, it becomes, you know, your Strangers repo to your own. It's like pretty easy now. It's reproducible, and yeah, just think about, you know, one thing that clicked and one thing that's still fuzzy, and the things that are still fuzzy, let me know. I'll stick around for another half an hour or so, and yeah, for any questions and stuff. But yeah, thank you for listening. Hopefully this was useful, and thank you for having me here.
Great, great. Thanks so much for this talk. I actually learned a lot, and I'm probably gonna start using this.
Yeah.
So I'm still stuck in Conda. Okay, so we now have about a little over 25 minutes for a break. We'll be back here in the auditorium at 3:30 for Wani Wu's talk on machine learning and biomarkers. So we'll see you all there in a little bit.